The exam scores in Professor B's stats class are normally distributed with a mean of 77 and a standard deviation of 7. So we're given in this problem that our mu is 77 and our sigma is 7. We want to know what score is so that 60% of the students score above the score. So let's think about what that means in terms of a picture. We're looking for some score, and we want the probability of being above that score or greater than that score to be 0.6. So we want our picture to look like this, where the shaded area to the right of the value we're looking for is 0.6. Now we know that our table is set up to give us probabilities to the left of a number or less than. And so if we think about the fact that the normal distribution has to have a total probability in this whole range of values of 1, what that leaves us for this part I did not shade is 0.4, because 0.4 and 0.6 will add up to the total of 1. So we're really going to look for here a z in our table where the probability of being less than that z is the 0.4. So to look for that in our table, we're going to go and look for a value of 0.4 as a probability. So we're looking in the big list of values in the body of our table. So we're looking through all these numbers here. We're going to see what we can find closest to 0.4. As we look through the table, we find that the closest value to 0.4 is this 0.4013. That corresponds to a negative 0.2 over on the side. And if we look at the top, we'll see that it's a 0.05. So what we get from our normal table is that this value of z is negative 0.25. That's the value that accomplishes 60% bigger than it and 40% less than it. We want to turn that into a score that we would have on this exam using the fact that we have a mean of 77 and a standard deviation of 7. So we can use the transformation that says you take your z times sigma and you add your mu, and that will get you back your x, and so we'll turn it into something that's on the right scale. So we have z looked up of negative 0.25. We'll multiply by our standard deviation, which is 7. We'll add our mean of 77, and what we get is a score of 75.25.